Hello, it's Rajita here. Today I thought of starting a new video series in my YouTube channel. Uh, we will do a basic Python course for numerical analysis. So what we are doing from today onwards is basic Python. For numerical analysis. So for the record, I'm not a Python expert, but I do know some Python for the use of numerical analysis that comes under um, applied mathematics. So this will be useful in many applications, applications in science, technology, engineering, as well as mathematics. So this will be the class number 1. Class number 1. I plan to do a total of 7 classes. There will be 7 total classes. So a number of classes. So this is the first one out of 7. So in this class number 1, I plan to cover some basics like how to install Python. I'll do the first section called variable names. Python operators. I'll teach you input function. Yes, this type called Boolean type, the topic Boolean. And comparison operators. Okay, that is the plan for today. In the next class, class number 2, I'm planning to do control flow structures. Like if, for, while. Okay, let's focus on what we are going to do today in the class number 1. So first we look at how to install this Python. So Python, you can go to your web browser and type Python in the Google search window. Then you will get the link to their website. Welcome to python.org. So there you go to their website, and then you can see this download section. Under that, you can download the latest version of the Python. So here they say that the Python 3.9, the versions of Python that come after 3.9 cannot be used on Windows 7 or earlier. So for all the versions of Windows, we will need some different version of Python. So you can install the Python depending on the version of the Windows you have installed. So you can check them here, view the full list of downloads. So it's a freely downloadable program. So once you download it, you can actually, what? You can open the Python command window. So that is one way of doing it. So what I would prefer, the way I would prefer to use is uh, the one called as Google Colabs. Okay, so so I can use Python on Google. So uh, to do that, what I do is I go to my Google Drive and open a new Google Colab window, a Google Collaboratory. So I open a new one. Okay. Mm, yeah, I can rename my file. I will call it class one. Okay. So I'll show you how to use these command cells as we go. So that is how you install Python, whether it's on your Windows uh, or how to use it on the Google Colabs. So that's fine. Next, we need to look at what are these variable names. Again, I should remind you that this is not an expert Python course. I'm covering the basic Python only for the numerical analysis purpose. So, uh, okay. So this one, wait a second. Okay. Now I need okay. So the first thing I'm going to do is the variable names. Let's go to variable names. So if you are familiar with a programming language like MATLAB or anything, you know what these variable names are. So the values and oh yes, the values are stored in variables. Similar to mathematical variables. In mathematics, we say a variable, something called like this. Let's say there's a function f of x. This is a one variable function. And we can write it as x squared plus 2x plus 1 or something. So this x is called a variable. We can change the variable and it will give a different value of f. So that is the variable in mathematics. It's a little bit different in Python. Here, let's say examples. I'll take an example. Let's say I equals 5. here the value 5 is stored on the variable I. Okay, that's fine. What else? So this we call the variable. Let's say x, we can get x is equal to 11. So this x is a variable. It doesn't have to be a single letter. It can be a word, something like this. Let's say my name. This my name is a variable, but like we cannot separate this separate them into two words like this, my space name. This is not considered a variable in Python. So let's try them on the Python command window. The first one is, let's say I equals 5. So if this works, if this successfully works, it will indicate to us that it works and it is correct. By this right mark here, the green right mark here, we are informed that the cell is run successfully. So this I is a variable, so that's not a problem. Let's say something like this: x equals 11. Now x is a variable. My name. So let's take my name. My underscore name equals 5. It works. Now the value 5 is assigned to my name. Let's take my space name. Name. So that is, let's say 5. Now it's not working. It gives us the syntax error, saying it's an invalid syntax. So this is not right. That's fine. So then we can check what is this my name is. We can write print my underscore name. Let's run this. So it gives the value of 5 because the 5 is assigned here to the variable my name. So that is fine. Okay. So that's about the variable. Next we can go to C Python operators. Python operators. There are a set of operators. The first one is addition. It is similar to the mathematical addition. It's the same. Example, let's say 5 plus 5 gives us 10. So 1 plus 2 equals 3. Okay. 5 plus 5, and we can execute 10. Then we can get 1 plus 2, it's 3. So Python is basically like some advanced calculator. The only difference is we can program this calculator. Okay. The other variables, sorry, the other operators are subtraction, let's say 5 minus 3 is equal to 2. Then multiplication is done by the symbol star. This is multiplication. Five multiplied by 3 is equal to 15. Then division is done by this symbol in Python. Let's say 10 divided by 2 is equal to 5. So let's see if Python gives these values to us. This is actually addition. Next, we need subtraction. 5 minus 3 is 2. And what else? Multiplication. Multiplication. 5 multiplied by 3. 5 star 3. It should be 15. And the next one, division. Say 10 divided by 2. This 5. Okay. So that's about the basic operators. There is something, let's say, how to get powers. Exponentiation, like exponentiation. Which means raising to a power of raising to a power let's say this. We know that in mathematics 2 raised to the power 3 is 8. How do we write this in Python? 2 raised to the power 3. So this is how we write it on Python. This will give us 8. Pronunciation. 2 raised to the power 3. Now this should give us 8. That's about Python operator. And then input. Let's say we write something like this. N equals input. Enter a number. We write input function, and within brackets we write within within these commas we write enter a number. So what this simply does is it asks from the user to enter a number. So we can execute this code to see what happens. See, it asks us to enter a number. Let me say 29. Then I press enter. Okay. Now, what happened to this 29? Is it stored to the variable n? It has to be, right? So we can print n to see if it has been stored. Yes, the 29 is assigned to n. We can also see the type of n. Type of n. So what this str means is it's a string, which means it's not saved in the format of a number. Let's say an integer or a floating point number. It's stored as like a word, a string. So let's say we want to save it in the form of an integer. So let me copy and paste this here. So what we do is we write int to abbreviate integer, the word integer. We write everything else within brackets. Okay. Now we can run this code. And again, it asks for a number. Let's say I write again 29. Press enter. Now I print in. It's 29. I check the type, type n. It's an integer, not a string, but an integer. Okay, that's fine. So that's a basic introduction to the input function. Next, we'll see what this Boolean type is. So the true false values, let's see, type true. We feel like this has to give us the the name string, as this is a word, but we'll see. So it gives us the type as its type as bool, which means Boolean type. Same with the false type, false. It's bool. So now we'll look at the use of this Boolean types. You might be wondering that already. So let me go to the next section, comparison operators. Um, okay, let me write it on the whiteboard. Next section is comparison operators. So how do we compare two values in mathematics? So in mathematics, we use this to indicate the equal sign. And this is less than. This is greater than. So on and so forth. But in Python, this is math. In Python, how do we do that? It is less than. And this is greater than. This is less than or equal to. Less than or equal to. Greater than or equal to. Hmm. Oh, I almost forgot it. This is equal to. So we write two equal marks on Python to indicate the equal to compare whether two quantities are equal or not. Not equal to is this one. not equal. So we'll check the application of that on Python command window. Okay. So we can check, let's say 5, sorry, 5 greater than 3. So we can execute this command and can you predict the outcome of this? This has to give us what? True or false? Since 5 is greater than 3, it has to give us true. Let's see. 5 smaller than 3. We know that 5 is bigger than 3. So if we write this 5 smaller than 3, it has to give us false statement. False. Let's say 5 greater than or equal to 3. So we know that 5 is greater than 3. So when we write 5 greater than or equal to 3, the statement is true because we know that 5 is greater than 3. Let's see this 5 smaller than 2 and 5 smaller than 5. 5 smaller than 5. What will be the outcome? Now, what about this statement? 5 smaller than 2. Is it correct? No. We know that 5 is bigger than 2. So this is false. Then this is 5 smaller than 5. This is also wrong. Or let's say false. This is false. And this is false. False and false. In order for the whole thing to give us a true value, both these two statements have to be true. But in reality, these two are false. So the total outcome is false. So we predict that the whole thing will give us a false statement. Yeah. The next one. 5 smaller than 2. 5 smaller than 2. Or 5 smaller than or equal to 5. Smaller than or equal to 5. Now we know that this is wrong because 5 is not smaller than 2. But we know that this is true because 5 is equal to 2. So since both are joined with the O comparison operator, in order for the whole thing to be true, either this or this has to be true. As this is true, we predict that the whole thing will be true. Okay. Now I think we have covered the intended sections for today's class. Okay. So that is what I want. Those are the topics I wanted to cover in the class number 1. So we will meet with class number 2 with our next video. I plan to do control flow structures that are if, for, and while. So I'll remind you that I'll be doing 7 videos, and this is the video number 1. So I'll see you in video number 2.